comes Ralphie.
RALPHIE is a radio and laser path-agnostic communication experiment, and I'm Duncan Bark, the chief engineer. RALPHIE is a 12U CubeSat being developed under the Air Force Research Laboratory's University Nanosatellite Program, and is flying Blue Cube's path-agnostic communication system and Amplified Space's software-defined power controller. The path-agnostic communication system, developed by Blue Cube, features a cobalt optical transceiver and bluefin X-band transmitter, which when combined with the networked radio allows for path-agnostic communication across multiple channels. The software-defined power controller, developed by Amplified Space, aims to speed up EPS development time and allow for modular power systems on CubeSats. RALPHIE is also being developed alongside Maxwell and Swarmex, two other CU CubeSats, and relies heavily on their development.
Hi, my name is Samantha. I'm the RALPHIE Structures lead. Structures is responsible for the design, analysis, and assembly of the spacecraft.
RALPHIE is currently a 12U CubeSat. It utilizes the space by incorporating a shelf that divides the interior into two levels. The bottom level holds the PAX payload, exact, antennas, and lithium radio. The second level holds the card stack, battery assembly, and GPS. Structures also design support equipment such as the flatset. Our current flatset design provides ample space for component wiring and testing, while allowing its mobility via handles and a cover. Lastly, RALPHIE has 3 solar panels, 1 body-mounted and 2 deployable.
Hey, I'm Alex, and I'm the subsystem lead for the attitude determination and control systems on RALPHIE. The main systems we'll be using for our attitude control are reaction wheels and magnetic torque rods. These systems will allow us to accurately point our optical communication payload to a ground station over 400 kilometers away.
In order to make contact with the ground station, the ADCS needs to control for 2 main sources of error. The first is knowledge error, which is determining where our ground station target is. The second is control error, which is how well the reaction wheels can point the laser at the center of the target. In the case of the cobalt optical transceiver, these errors both need to be less than half a degree combined.
To meet these high pointing requirements, we will be using Blue Canyon Technology's Exact-15. This is an off-the-shelf component, so we won't be designing our own control algorithms, but there are many opportunities to get experience modeling, testing, and implementing this state-of-the-art system.
Hi, I'm Madeline, the Electrical Power Systems lead for RALPHIE. RALPHIE will use a solar array and battery pack at 24 volts maximum with 46.2 kilowatt hours to support all the power needs of the mission.
A power budget has been developed to confirm that these systems will be able to provide enough power to complete all stages of the mission. In addition, a software-defined power controller that's being developed by Amplified Space is being used as a display of technology. This will dynamically regulate the charge current to the battery in the RALPHIE mission. Additionally, a battery management board is being developed to passively balance battery cells and transmit temperature and voltage data to other controllers. Additional hardware like the EPS board and CDH board use legacy hardware from the Swarmex CubeSat mission.
CDH is responsible for the designing and testing of the CDH board, which is used to control and command the spacecraft. This board will feature the DS-PIC33 microcontroller and various modes of communication with the various subsystems of the spacecraft. CDH also works very closely with systems in developing the concept of operations, which includes modes, mode switching, and integration with our various ground stations, which includes a LASP ground station for the UHF radio, and a CU optical telescope for the optical ground station. In the near term, RALPHIE is targeting its critical design review scheduled for fall 2023, and then after that, the flight selection review in early 2024, which is when UNP selects projects for continued funding into Phase B for hardware acquisition and further development. Currently, RALPHIE has 18 members ranging from undergraduate volunteers to graduate students participating in the Graduate Projects course. If you are interested, there are many ways to contribute, so please email below. Thank you.
Here comes